Relations, functions, domain, and range. I'm not going to go over all of this because I've already made videos, and hopefully you're seeing a link for those videos. They're made for an intermediate algebra class, so make sure you watch those first. You may not need to watch them all, but you can skip around, but they're highly recommended. So what I'm going to do, I'm going to focus on examples that are not in those other videos. So here's the first one. We're going to find f of x plus h minus f of x over h. This is actually a slope formula in calculus, so if you're planning on taking calculus in the future, this is something that you might see. So first thing we want to do, we want to find f of x plus h. And hopefully you've already seen those other videos that I've already mentioned. And if you have, then you probably have seen similars where I said if you're asked to find f of x plus h, and this is your given function, that whatever is inside the parentheses is substituted for the x inside the function. So you may see me write it like this, and this is the way I'm going to write it. So what goes inside here, inside these parentheses, or what's inside these parentheses, which is x plus 7. So once again, or x plus h I should say. So once again, all I've done is taken the given function and replaced the x with x plus h. And then I'm going to clean it up, multiply out to 2, and we get 2x plus 2h plus 7. Now f of x is given to be the function, and then h is just a variable, a letter. So now what we're going to do is take our information that we found and that we're given, and we're going to substitute it into this formula. And so what is it? F of x plus h? Well, we found it to be 2x plus 2h plus 7. I'm going to put that in parentheses just so that it's going to be different from f of x. And I'm definitely going to put f of x in parentheses because of the minus sign. So f of x, we're told, is 2x plus 7. You definitely want to use parentheses, especially for expressions after a subtraction sign. That's going to be all over h. H is just a letter, h. So now all we're going to, well, let me just go back and review what I just did. I found f of x plus h first. So that's what's up here. And all I did was take the x plus h and substitute it for the x. That's what I did down here. And that cleaned up my answer. So that answer goes for f of x plus h. And then f of x was given to be 2x plus 7, which I put there. And then h is our denominator, and it stays our denominator. So now all we're going to do is clean up our problem. Just clean up the numerator first. So I have 2x plus 2h plus 7. I don't need the parentheses. But then this minus sign, I'm going to distribute. We're going to get negative 2x. Then negative times the positive 7 is a negative 7. And I'm going to bring down the h. Now what I'm going to do is clean up my numerators. I have this 2x and this minus 2x, which becomes 0, which means they cancel out. Then I have 7 minus 7, which is also 0, and that cancels out, leaving 2h over h. Now, this 2h was from the numerator, and then my h that's on the bottom, the denominator. Then these h's will cancel, because they equal 1, and then 2 times 1 is just a 2. And that's my final answer. All that work for an answer of 2. Now this next question, or example, actually is from the Hawk system. You're given this relation, and you're asked to write it as a function of x. Now all that means is we want to solve for y. And the reason why we're going to solve for y is because f of x is just another way of saying y. So let's take the original problem and solve for y. So we're just going to treat it like a normal equation. I want this y term by itself, which means I need to get rid of the 2x. So I'm going to get rid of the 2x by subtracting 2x, because a positive 2x minus 2x cancels each other. I'm going to write the negative 2x underneath the negative x on the left side. Right side, these do cancel because it equals 0 and it leaves negative 3y. On the left side, I have negative 4x squared, and then negative x minus 2x, or negative 1x minus 2x, is minus 3x. Now what I'm going to do, to get the y by itself, I have negative 3 times y, so I'm going to divide. You don't have a multiplication when you use division to cancel it out. And what I'm doing on the left side is I'm going to divide each term separately by the negative 3. Each term. That's the best way to do it. These negative 3's cancel out, or become a 1, and 1 times y is y. And then a negative 4 x cubed divided by negative 3, and negative divided by negative is a positive. So all I'm doing is just cleaning up the left side now. Negative 3 divided by negative 3 is a positive 1 x, where you can say 3's cancel and the signs become positive. And I get down to y. Now I don't want to leave it as y even though I can, but I want to use function notation, so I'm going to write it as f of x. And then this is going to be my answer. I'm going to leave out that 1. F of x equals 4/3 x squared plus x. Now the second part of the question was evaluate the function at x equals 2. So all that means I'm going to do, I'm going to take the function I just found and find f of 2, which means that everywhere I have an x, I'm going to put a 2. Highly recommended to use parentheses whenever necessary. So now we're going to clean it up. 2 squared is 4. You got to do exponents first. And when you multiply fractions, you multiply straight across. So you get 16/3 plus 2. To add fractions, you need the LCD. So it's going to be 3. 3 and 1 both divided into 3. So 1 times that by 3 times that by 3. We get 16/3 plus 6/3. And the final answer is 22/3. Or you could have done this. Remember, we were asking 16/3 plus 2. You could just went 16. Wait, let me turn it on. 16. Let me go back. 16/3 plus 2. And then hit math. Enter. Enter. We could have done it that way also, if you have a graphing calculator. So, once again, I'm not going to do all these examples. You can look at the other videos I've mentioned before. Domain and range, that's throughout those other videos. Just remember, domain is the x values and range are the y values. I'm going to focus on the ones that have fractions and square roots in them. But before I do that, I'm going to do an example. Make up an example for you. Just give you an idea of what's going on. Once again, make sure you watch those videos. Now all these are counting my ones. So let's just say I have this, and it goes something like this. So I'm going to use D for domain. Now domain is left or right. So if I were to ask you how far left, and this is open circle, it's not a 0, it's an open circle. So what you might want to do, what you could do, you could actually label this point. It's left 3 down 2. So how far left does it go? Well, I only care about the x value for the domain, so it goes to negative 3. But since it's an open circle, I'm going to use parentheses. And then the curve exists throughout. And this actually isn't a function, by the way. The one I drew is not a function because it doesn't pass the vertical line test. So I could easily have said find the domain of the relation. So as far left as it goes to negative 3, but then all the way to the right, if I were to label that point, it would be 3, 1. So it does go all the way to 3 on the right. Now, is that 3 included? You would say yes, because it's a closed circle, which means I'm going to use a bracket around that one. So domain's left or right. range is down to up. So how far down does this curve go? It goes all the way to -2. It doesn't go past it. And it exists at -2, which means I'm going to use a bracket. But then how high does it go? What's the highest y value? Well, this is the highest point. And what's the highest y value? Well, it's that 1 right there. And that 1 is included because of the graph being included. So it's just a reminder, and if you need more information, make sure you watch those other videos. Now what I'm going to do some more examples involving functions, this time actual equations. I highly recommend whenever you need to graph them. So let's just go ahead and graph y equals square root of x. So I got y, and I'm going to type in square root of x. And hopefully you'll recognize what these shapes are. And so you'll see that it is this curve over here. And so what we're going to do is we're going to do the domain. I think that's all I'm asking you to find. Yeah, let's just find the domain. So when you find the domain, you're asking yourself, how far left does it go? And so when you look at it, you're thinking that it does go to 0. So one way to find out to make sure, you can look, or two ways really, you can look at your table and see that it does exist at 0, and you'll also see that if you go into negatives, you'll see a bunch of errors. But it does exist at 0. You also could have hit trace 0 and then enter, and you'll see an answer for the y. What that's telling you is that it goes all the way to the left to 0, and the 0 is included. But then to the right, it keeps on going forever and ever and ever. So we call that positive infinity. And now we always use parentheses around infinity. Now before I do the 1 over x example, I'm going to do another example involving this. And then we're going to talk about a way to do it algebraically. So if I were to do absolute value of x minus 2, I can just type in absolute value of x, or not absolute value, but square root of x minus 2. If I've been saying absolute values, please forgive me. I meant to say square root. So square root of x minus 2. And it looks like the same shape, except it's been shifted over. In fact, 2 places to the right. So the only question is, does it exist at 2? It doesn't go to the left of 2, but does it go to 2? I prefer to use the trace button. So if I hit trace 2, enter, do I get an answer? Yes. 0 is an answer. So anytime I get an answer, that means it does exist. So how far left does it go for the domain? It goes 2 to the left, and I do include it. And then to the right, it goes forever. Forever. Now, if you know anything about square roots, since we're always working the real number system unless we're told otherwise, we know that we can't take the square root of a negative number. So if you were to find the square root of -4, for example, you get an error because you can't find it. So what you could have done, if you don't have a calculator or misplaced it, you can actually just find out when it comes to the domain, is find out where we call this the radicand. X minus 2 is called the radicand. We know it has to be bigger than 0, but it also can be equal to 0 because you can find the square root of 0 and get an answer. See? 0. You got an answer. So all we really need to do is just set x minus 2 greater than or equal to 0 and solve that expression. X greater than or equal to 2. And if you were to graph that on a number line or think about it, you would see that's the same thing as everything from 2 to infinity. So there's two ways to approach this. You can just graph it, or you can do it algebraically. Now let's look at the 1 over x example. Let's graph it so you can see how ugly it actually looks. Now here's how that really looks, the actual shape of it. It's actually looking something like this. The calculator may not be showing you what you want to see, but this is what's going on. It's going forever to the left and to the right, but as it comes from the left, it doesn't get to 0. It like jumps over to 0, then it takes off again everywhere to infinity. So if we go from the start from the left like we always do, it is coming from negative infinity, which we always use parentheses for infinity. Probably don't need to use that. Just make our infinity symbol correctly. So it goes from negative infinity, and it comes from negative infinity, and it gets closer and closer and closer to 0. And we're not looking down, we're looking to the right, but it never gets there. So we use a 0 in the parentheses, showing that it jumps it. So it's going to jump it and take off again from 0, but not at 0. Then it goes forever to infinity. Now we need something in between to join these two together. We'll use the union symbol. So let's do another one of these examples, just so you can have an idea what's going on, just to make sure. Let's look at f of x equals 1 over x plus 2. Now when I type this in, I want to make sure that I use parentheses around the denominator. If I'm not sure, I'm always going to use parentheses. And so you see a similar kind of shape that's been shifted over. Now if you look at it, it's actually over left 2. That's that negative 2. Now you'll see a line in the middle that's not there. It's called an asymptote. So I'm going to draw a dotted line. You'll learn more about this later on in class, but this is what's going on. This is how it looks. And then I'm going to draw the shapes that were very similar to 1 over x. It's just a 1 over x shape shifted to left 2. Now the domain, once again, we're going to look to the left. So it does go forever to the left, negative infinity. And it gets closer and closer and closer and closer, but doesn't ever get to negative 2. So we use parentheses around that. It jumps it. We use the union symbol. Takes off again from negative 2, but not at negative 2, and then goes all the way to the right forever to infinity. And you can do a couple of things. You may want to look at the table and just to verify that at negative 2 it doesn't exist. And you can always use trace negative 2. Well, you don't want to use that. You want to use negative 2. And you don't see an answer. It doesn't pop up. So the moral of the story is when it comes to rational functions, your denominator, in this case x plus 2, it cannot be 0. So anytime you're dealing with fractional expressions, it cannot equal 0. So all you really are doing is just setting x plus 2 set equal to 0. You probably won't think of it as not equal to 0. And then you solve like you normally would. And it's just telling you that x cannot be 0. Well, we don't want to say 0. We want to say x cannot be negative 2, which is what this is saying also. It's everything but negative 2. So it comes from negative infinity to negative 2, jumps over negative 2, and then goes from negative 2 to infinity again. I think that's the last example here. So once again, make sure you watch those other videos.